Hello everyone, today I will update revision video 8 for the course Fuzzy Set Logic and System and Application. In this video, I will discuss 8 videos of the content which is shared with us, video 23 to 30. In this video, there are 3 categories, 24, 25, 26 belongs to one category and 28, 29, 30 belongs to another category, and video 23 belongs to a single category in which there is a concept of complement. So in this model, a complement of fuzzy set. So there are two types of complement, Sugeno and Yagers. So Sugeno class of complement is defined by this. We have to remember this formula only, and we can solve the questions based on this. And in this case, the value of lambda belongs to in this range. Means lambda cannot be equal to -1 and lambda cannot be equal to infinity, right? And in this case, if lambda becomes 0, then this will be the simple case of complement, right? Simple case of complement. So if in the question, if they are asking when lambda equal to 0, then simply just take the complement for the given membership value. So this is the case, and I already discussed the same type of question in the assignment videos, so I will not discuss it here. So with the help of lambda is equal to, in this case, minus 0.8, and lambda can be 0, lambda can be 1 and 2. According to that, this value will be changed, right? So we can compute them. So this is the case when lambda is equal to 0.8, means this is the case. When lambda equal to 0, this is the case. When lambda is equal to 1, this is the case. And when lambda is equal to this is the case. So in this way, our membership values changes. Complement of fuzzy set Yagers. This is also very important, and it may be possible in the final exam instead of what we have discussed right now. We can be asked for Yager's complement, right? Instead of Sugeno, Yager's complement can be asked. So we have to take care of the formula. In this formula, W, in that in Sugeno there is a term parameter lambda, but in this case there is a parameter W, and W in the range of 0 and infinity, both are the excluding term, right? And this is equal to 1 minus mu a x uh, and the power W and whole raised to the power 1 upon W, right? For each value of the parameter W, we obtain the complement of fuzzy set. So these are the based on two axioms, so no need to cram them. Note, if W is equal to 1, then in this case it becomes a simple uh, complement, when because mu ax raised to the power 1, it will remain same, and whole raised to the power 1 upon 1, it will again same. So that's case of simple complement. In Sugeno, when lambda equal to 0, then it becomes a simple complement. So in this case also, just if we have to calculate Yager's class of complement, this will be given to us 0.71, 0.52 this, and W is equal to 0.5. So how we have to tackle? C 0.5 mu x is equal to 1 minus mu ax raised to the power 0.5, right? And whole raised to the power 1 upon 0.5. So most probably in final examination, instead of Sugeno, it will be Yager's. So just remember this particular formula. So we can calculate all these things, not a big deal, just remember the formula. And in the same way, when W is equal to 0.5, this will be the output. W is equal to 1, this will be the output. W is equal to 2, this will be the output, and W is equal to 3, this will be the output, right? This is a comparative analysis when value of W is equal to different. So video 24 to 27 are very important, and in this video there are concept of T norms or S norm operator, T norms and S norm operator, and T norms also known as, but in first I will discuss T norms. T norms other name is S conorms, right? And in the same S norm is also known as T-Conorm. So not a big issue. So this is the formula. T norms mu ax oblique mu bx. This will be equal to mu a intersection b, right? So this is the sign is the T norm operator, and the T norm operator is also known as S conorms. So don't be confused in this. So for a function T to be qualified as a fuzzy intersection, it must satisfy at least the following four requirement: boundary condition, it must be commutative, it must be non-decreasing, and it follow the associative property. Right? If all this property will be satisfied, then it becomes a T norm. Right? So these are the basic formula which must we have to take care. So there are four commonly used T-norm operator, minimum T operator. In this, what we have to take care, we have to select the minimum value among the membership value of forum fuzzy set A and fuzzy set B, right? So this is the case, minimum value. So this is basically AND operator. So we have to take care, and we have to select only minimum value. Algebraic product. In algebraic product, just we have to multiply the membership value, right? Very simple operation. With the help of example, we can see them in next 2, 3, 4 slides. Bounded product. In bounded product, what we have to take care? First, uh, we have to take the union. We have to take the union of what? 0 and membership value of mu A plus mu B minus 1. Okay, and after that 1 is this one, and whatever be the output will come, and another is the W, and we have to take the union value. This is the OR operator, or we can say union. Dragatic product. So in this case, mu AX, we have to consider the membership value of mu AX. But when the membership value of mu BX is equal to 1. And in this case, it is vice versa. And when membership value of fuzzy set A and fuzzy set B less than 1, then it will be considered 0. So just this is the case. So how we can calculate fuzzy set A, fuzzy set B, right? So 1, 2, 3, 4, 2 or 3. So what we have to take care? We have to add 1 and 4 with membership value 0. So finally, these are the two fuzzy sets. Minimum. So out of this 0.7 and zero point 0, minimum is 0. So we have to consider 0. Uh, in this case, minimum is 0.5, 0.8, minimum 0.5. In this case, 0.1, 0.3, minimum is 0.1, and 0.60 minimum is 0.0. So in this case, we can take care. So not a big issue. And in the case of algebraic product, just we have to multiply, right? So this is the same case. Minimum value we have to consider. In case of multiply, 0.7 multiply 0 becomes 0, right? So minimum point multiply 0.5, 0.8, that is 0.4, right? Minimum 0.1, 0.3, and when multiply, so it will becomes 0.03. In the last case, minimum 0.6, 0.0, and when multiply it becomes 0. So in this case we can take care. So minimum and algebraic product. In algebraic product, simply just we have to multiply the membership value. T norm. So first of all, what we have to take care, there is one membership value that is 0, another is the membership value mu A plus mu B minus 1, right? So 0 union 0.7 plus 1 minus 1, that is minus 0.3. So minus 0.3 or 0, so we have to consider 0, right? 0 and 0.5, 0.8, that is 1.3. 1.3 minus 1, that is 0.3. So union of 0 and 0.3, that will be 0.3. So in this way we can solve them. 0.3. So this will be the our final answer. Last one is the Dragatic product. So mu ax will be equal to when mu bx is equal to 1. Otherwise it will be less than 0. So in this case mu ax will be equal to 0 or 1. We have to take care about this particular formula, right? So 0.7 oblique 0, right? So here it will be 0 again. In this case also it becomes 0, and so on. So all the membership value in this particular question is equal to 0. Now T-norm or S-norm operator. Now I will discuss S-norm, and this is also known as T-Conorm. So same things as we discussed in T-norm, right? There's a little bit difference. For the function S to be qualified as a fuzzy union, right? Earlier it was fuzzy intersection. So these are the four axioms which must be satisfied, and after that, if this is satisfied, then it will be called S-norm operator. So in the same way, this operator also having four property, right? Maximum algebraic sum. In earlier it was minimum, but in this case it is maximum algebraic sum. At that time it was algebraic product, bounded sum, and Dragatic sum, right? So how we will evaluate mu a? So it will be the case of union algebraic sum. This will be equal to mu ax plus mu b minus mu ax into mu b x, right? So bounded sum, in this case 1 intersection mu x plus mu b, and this will be mu x is equal to if mu b equal to 0, mu bx is equal to if this. So we have to take care of this formula. With the help of example we will take care. S-norm operator, this is the question. AB maximum of this is 0.7, so this is the 0.7, maximum 0.5, 0.8, that is 0.8, maximum 0.1, 0.3, 0.3, and 0.6 and 0, maximum is 0.6. So first property, and an algebraic sum, so mu ax plus mu bx uh, plus minus this, so 0.7 plus 0, and when we multiply both of them, then again it will be 0 and 1. So with the help of this particular formula we can evaluate all of them, bounded algebraic sum, right? In the same way, bounded sum, in the case of bounded sum, one intersection, earlier it was 0 union and this. So we have to take care about this formula. S norm or T norm, one intersection mu ax plus mu bx, right? Just apply that particular formula and we can get the answer. In this case 0.71, so we have to take care about this formula and we can evaluate 0.70, right? This mu x if mu bx equal to 0, right? Otherwise it will be mu bx if mu x is equal to 0. So in this case 0.7 oblique 0, 0.7 oblique 0. So in this case mu bx is equal to 0, therefore value will be equal to mu ax, therefore 0.7 will be considered as it is, right? So 0.5, 0.8 oblique 2, if mu ax and mu bx greater than 0, if out of them both are greater than 0, then this will be equal to 1. So this will be equal to 1 because 0.5 and 0.8 greater than 0. 0.1, 0.3, again both are greater than 0, therefore 1. And 0.6 and 0, again mu b equal to 0, therefore it will be remain equal to mu ax, again it will be 0.6. So these are very very simple, just calculation, and just we have to keep the formula in our mind. So these are the extended version of parameterized T-norms and S-norm operator. First I will discuss T-norms. In T-norms there are three type of these operations: Dombey class of T-norm, Debye Praed class of T-norms, and Yager's class of T-norm. But I will suggest you don't have to remember all these things, because this type of question can't be asked in the examination, because mathematical calculation very at high scale. So T-norms, and first I will discuss the Dombey class. So directly take care about this formula: 1 upon 1 plus this one, and lambda belongs to in this particular range, right? So when we will calculate, and it will become very very complex for calculation purpose, that's why it will not be asked as per my perception. But if you have the power to cram, you can just go ahead. The fuzzy set A and B given as this: Dombey class of T-norm for lambda equal to 1. So put the value of lambda and evaluate all these things. This is the fuzzy set A, this is fuzzy set B. So first we have to take 0.7 in this and 0.1 in this, right? So this is the 0.7 and this is 0.1, right, for fuzzy set A and B. In next we have to 0.8 and this is 0.5. So in this way we calculate, and it will take time, so not easy, therefore it would not be asked in the final exam. Same Debye Praed class, same we have to take care of the formula. It may be possible mu ax into mu b, maximum of mu x mu b, comma alpha. So alpha belongs to in the range 0 and 1, both are included. So formula simple, same question: fuzzy set A, fuzzy set B, and for alpha 0.1 we have to calculate. So put it in formula: 0.7 and 0.1, 0.7, 0.1, right? And again maximum of 0.7, 0.1, that is 0.7 multiply 0.1, it becomes 0.007, and maximum of 0.7 and 0.1 comma 0.1, so maximum is 0.7, therefore out of them we have to consider 0.7, so this becomes 0.1, and in this case 0.40, maximum 0.5, 0.8, and 0.1, so it becomes what we have to consider, that 0.8 maximum, that is 0.8. So in this we calculate. So this is easy to cram, therefore we can go ahead with this. Yager class, again this is so complex and unable to compute, because we have limited time: 1 minus minimum of this w plus and so on. So just I am skipping fuzzy set A, fuzzy set B, and just for value of w1 we can compute in this way, right? Parameterized T norms. Now I will discuss S norm. In the same S norm, there are again same three class of Dombey, Dubious, and Yagers. Again, we have to take care of the formula. In the formula, there is a little bit changes: minus lambda, right, and minus lambda. These are the slight changes. Again, same set of pair question will be there: fuzzy set A, fuzzy set B, and again for lambda is equal to 1, we have to calculate this one. So dubious period of class for specific S norm. So this is the formula, but in this case it is a little bit difficult: mu x plus mu b minus this, minus minimum of this, and 1 minus alpha, max of this. So I would not suggest for final examination. So just go ahead with the rest of the normal Sugeno and Yager's class of complement. Last one is the Yager's class. Let this one is equal to A, and this is the formula. So it can be easy to grab, but we don't need. So fuzzy set A, fuzzy set B, right, and put the value of W is equal to 1, and we can evaluate. So this is very important. Video 28, 9 and 30, fuzzy relation and crisp relation, right? This is the crisp set A, crisp set B. So what will be the Cartesian product of this crisp set? So what we have to do? We have to take the first element 1 and we have to multiply, or simply we have to make a pair, 1 with 2, again 1 with 3, and again 1 with 4, right? So these three pair will be uh, appear, right? Again we have to take second element, that is 2, and pair with rest 3 element, in this case again 2 2 2 3 2 4, 2 2 2 3 2 4, and again third element 3 2 3 3 3 3 4, and so on. Total 12 pair will be there. So this is the Cartesian product of a crisp set, right? Now if we want to find out the relationship, now there will be some statement will be given, right? What? The relation Q2 AB such that the second element is greater than the first element, means in this second element, in this particular Cartesian product, second element is greater than first. So these are the options which are available to us as per the given statement. Second element is greater than first element, right? 2 is greater than 1, 3 is greater than 1, because 2 and 3, 4, these are the second elements. Now if we want to find the relationship between them, how we can find? Where in this case this is A, write down A 1 2 3, and in this case B 2 3 4. So only for this particular uh, set of value we have to put the 1, rest we put the 0, because only this particular cases condition is met, therefore we will put 1. Therefore why we are putting 1? Because it is a part of crisp relationship, either we can put or 0 or 1. That's why we are putting 1 for the uh, case which are true. In the same uh, with the help of, this is the fuzzy set A, this is fuzzy set B, find the Cartesian product. So point 2, point 3. First of all, what we have to do? We have to take the minimum. Point 2, point 3. Minimum is point 2, therefore we will consider point 2. Again, point 2, point 9. Minimum is point 2. Again, we have to do. This way we can find the Cartesian product of fuzzy in fuzzy. So this is will be our final answer, and this is known as the fuzzy relation. Fuzzy relation. In this value are not equal to 0 1, because that is only applicable for crisp relation. But in this case it is fuzzy, that's why value are not 0 and 1. So operation on fuzzy relation, there are 4 type of operation: union, intersection, complement, containment. So I will not discuss all these operations because very simple, I already discussed in my assignments, so you can take care. So these are the just example. Cartesian product, crisp set A and B. First of all, find the Cartesian product as per the given statement. Just find out the uh, appropriate relation, and after that you can highlight the crisp relation, whether it satisfy, put 1, else 0. In the same way, fuzzy relation, set A and set B. In set A, this is the relationship set between set A and set B, and this is another relationship S. So what we have to find out? So this is first relationship, this is another relationship, and we have to find the union. Just we have to take the maximum value ship. So 0.3 and 0.3. So both of them maximum is 0.3, that's why. 0.2 and 0.0, 0.2 and 0, maximum value is 0.2, that's why this. So in this way we will calculate union, you can intersection, and we can intersection and complement. So thank you so much, and best of luck for the final exam, and I hope so this video help a lot to all of you guys. So thank you so much.